Welcome to the 14th hole of the Adventure Golf Unit. Today we are going to be putting together some of the information we learned on the last couple holes and looking at composite figures. When we're looking at the area of a square, just a quick review here, we're going to take the side length squared. Area of a rectangle is base times height. Area of a parallelogram is base times height, with our base and height having to be parallel. In some cases base and height having to be perpendicular. And our height sometimes is an altitude when it falls outside of the parallelogram. A triangle is half of any of these parallelograms, so we would do base times height divided by 2, or we could do base times height times 1/2. And again, my height or altitude must be perpendicular to my base. The area of the trapezoid, we are going to average our two bases, and our two bases are the two sides that are parallel, the pair of parallel sides. So to average them, we add them together and divide by 2. And then we have to multiply by the height, and again the height is perpendicular to the bases. Area of a circle is pi times radius squared. Circumference of a circle is pi times diameter, or 2 times pi times radius. If I double my radius, I get my diameter. When I'm looking at a composite figure and trying to find the area, if you look, it's got 1, 2, 3, 4, 5 sides. This is an irregular pentagon. It's irregular because my side lengths are not all congruent, my angles are not all congruent. The most challenging part of this is splitting this into shapes that I do know formulas for. So if I look at this pentagon, if I split this on the height right here, I actually have on this side, let me make my highlighter bigger. Over here, my yellow figure becomes a trapezoid. And my light green figure is also a trapezoid. So I've got two different trapezoids that I can add together and find the area of my pentagon. If I look at my yellow figure, my bases, or my two sides that are parallel, are 8 and 4. So 8 plus 4 divided by 2, 12 divided by 2. And my height is perpendicular, so perpendicular to my parallel sides would be 8. So 8 plus 4 is 12, divided by 2 is 6, times my height of 8 equals 48. So the area of this trapezoid would be 48 centimeters squared. Now I must find the area of this trapezoid. My bases here, my pair of parallel sides would be 6 and 8, and my perpendicular, or my height, would be 8. I'm sorry, 6 and 12, and my height would be 8. So add my two bases together, 18, divided by 2 would be 9, times my height, 9 times 8 would be 72. So this trapezoid over here has an area of 72 centimeters squared. Now, if I want the area of this whole shape, I must find the sum of these two. So I take this 2, put it with that, that's 50. 50 plus 70 would be 120. So you can see I just split into two shapes, found the area of each, and then I put them back together. If I look at this shape, I can split this a couple different ways. First off, I'm going to peel off this triangle right here. This is a right triangle. And when I look at this shape over here and the rest of this, I have a right scalene, and then I have a trapezoid. So my right scalene, my base and height must form a right angle. So my base would be 50, my height is 120. I'm actually going to do 120 divided by 2 times 50. 60 times 50 would be 3,000 yards squared. And you can see how I used the commutative property there to make that a problem I could do mentally. So this triangle, 3,000 yards squared. Base times height divided by 2. And then my trapezoid over here, I have to average my two bases. My bases are the pair of parallel sides, 190 and 60. Adds up to be 250. And then I take that 250 divided by 2, I get 125, and I multiply it times my height of 80. 125 times 80 gives me an area of 10,000 square yards. And what I end up with is an area for this entire figure. 10,000 plus 3,000 would be 13,000 square yards. So base times height divided by 2. Average my bases, add them together and divide by 2 times the height. And then I put these two formulas together. If I look at the shape here, it's a little bit fuzzy. But we're going to do the same thing. In this shape, you can actually divide a lot of different ways. The one thing I want to point out is we do not have a height here, and we do not have a length here. So we need to use reasoning to figure out what those would be. This entire shape is 10 centimeters across. If I start here, I've used up 3, and then I use up another 3, which is a 6 total, and then I use up 2 more, which is 8 total, which means I have 2 centimeters left for this length. And if I go from the top down, I have 6, 7, 8, 9 from top to bottom. I've used up 3, 4, 5, 6, means that that is 3 centimeters as well. So I've just used some reasoning to find those two unknown lengths. I'm going to go ahead and separate this into 3 rectangles. And here I've got a height of 3 and a base of 10. Base times height equals 30 centimeters squared for this bottom rectangle. This has a height of 3, and going across it's 2 here and 3 here, so this is actually 5 all the way across. 3 times 5 equals 15 centimeters squared. And then this top is actually a square. It's a rhombus, meaning that it's 3 by 3 by 3 by 3, and it's also a rectangle, all 4 right angles. When it's a rectangle and a rhombus, we call it a square. 3 times 3 is 9 centimeters squared. Now I need to find the sum of these. 9 plus 15 is 24, plus 30 is 54 centimeters squared. Now we've got a little different figure. We've got a rectangle and then a half circle. So the rectangle would be, I'm going to actually write this out in one long formula so you can see when you have different pieces you can just put the formulas together into one big formula. Base times height, 14 times 20, plus I need to add on the area of this half circle. And if this entire diameter here is 14, my radius would be 7. So I'm going to go pi times my radius, which is 7, squared. That would give me the area of an entire circle, but I only have half a circle, so I must divide it by 2. So I've got 14 times 20 gives me the area of this rectangle. Pi times 7 squared would give me the area of an entire circle, and then I divide it by 2 because it's only a half a circle. So 14 times 20 plus pi times 7 squared divided by 2. And a rounded answer here would be 356.97, and my units would be centimeters squared. So this is the rectangle, this would be an entire circle, that's the half circle. Looking at our figure here, I've got a triangle, a rectangle, and a parallelogram. If the height of this triangle is 7, and the height of this rectangle is 3, that uses up 10. If 16 all the way across, this altitude here would have to be 6. So my parallelogram would be base times height, which would be 6 times 9. And then I would need to add my rectangle. If this is 9, it's a parallelogram. This is 9. If it's a rectangle, that's 9, which would be base times height. So 3 times 9. plus I need to find the area of my triangle, which is base times height divided by 2. So I need to add my base of 9 times my height of 7 divided by 2, and this will give me my area of this entire shape. 6 times 9 is 54 plus 27. So the 27, 54, these two make up 81. My triangle would be 9 times 7, which is 63, divided by 2 would be 31.5. So I add to this 31.5, and I get 112.5. And there are no units actually given, so it would just be units squared, 112.5 units squared. So I'm finding the area of each individual thing, and then I'm adding them together. This is the last example we're going to look at, and you have 3 half circles that we're dealing with. The first half circle that I'm going to look at is going to be this entire half circle right here, up here. And the area of this entire half circle would be pi times my radius. So my diameter is 6.5, so my radius would be 3.25, half of the diameter, squared. And that would give me an entire circle, pi times 3.25 squared, but it's only half of a circle, so I need to divide by 2. That would give me the area that I've shaded in green. I need to subtract out this little piece that's missing over here. And you can see that it's making my highlighting. So I need to subtract out that. And the area of that would be pi times my radius. My diameter is 2.5, so my radius would be 1.25 squared. That would be for an entire circle. I have a half a circle I'm taking out, so I need to divide by 2. So I found all of this half, and then I subtracted out this piece, and then I need to add to it this down here, which would be pi, and my diameter here is 4, so my radius would be 2. Pi times radius squared, that would be for a full circle. It's only a half a circle, so I need to divide by 2. So you can see I've gone step by step and created one large equation. And I'm just going to use my calculator to punch that in. Pi times 3.25 squared divided by 2 minus pi times 1.25 squared divided by 2, because it's a half a circle, plus pi times 2 squared divided by 2, because it's a half a circle. And my area of this shape is 20.42, and that's a rounded number, and it would be in centimeters squared. So to summarize, when you have a composite figure, break it into smaller shapes that you recognize and have formulas for, and then put together or take away whatever you need to do to find the area of the shape that's left. At this point, you are ready to get online and print out the scorecard.